Hey everyone, welcome to another Open Cluster Management Community Meetings. Today is January 26, 2024. QJang has a topic queue up for today. QJang, please take it away. Thank you.
Yeah, so I can share some progress on the code refactor, like the discussion from last week, and then I think Zhujian has did a very cool demo, has did a very cool thing about using the add-on template to deploy the fluid. Maybe he can demo later on that. I can just at first share some existing code structure change. Let me share my screen. Yeah, so it won't take quite a lot of time, maybe just 5 minutes. So at first we initiated a repo called SDK Go. In this repo, we are currently putting several things. One is all the APIs helpers. The API helpers functions are organized based on the API group and the version. So currently there are several for the four kind of different helpers. There is a rollout helper that is currently being used by both add-on and add-on framework and manifest replica set, and potentially it could be also used in the policy in the future. And also there are some helpers for placement to get placement easier and the cluster set helpers functions. And in the work repo, this is also previously in the API repo, and we are moving to here. It's like common work helper functions that you can build the manifest work directly from the set of the manifest object or runtime objects. And then, for example, here you can like define a list of the manifest objects and then the work builder can help you to build the manifest work. So also can set some different options like the delete options and configure options in the builder. So there's another called build and apply. So with build and apply, in addition to build that to a manifest work, it also help you to apply that to the ACM hub. So at first you need to define a runtime client. The client can be a typed client like the work client or a client in the controller runtime. It's more like the controller runtime client. So this two client is supported. So to do that, they just do the work apply and apply function and apply the manifest work. This is a different from this is different from what the original client can do because we also have a local cache in the manifest in this helper function. So when the manifest work is updated, so we will compare the manifest work with the local cache which include the spec hash of the manifest work. So they with that we can understand. So it will help you to reduce the number of calls to the ACM Hub API server. So this is one part of the APIs. That is all the not APIs, the utility functions for different APIs. Another part is cloud event helpers, and this is also has been removed from the API repo. So the cloud events part, including the part that define what cloud event we want to push. Like currently it's more like similar at the manifest work, but it's in a cloud event format. And then we are having kind of in the option part, we can have different types of the cloud event client that we are currently support. So currently there are gRPC and MQTT. There's YAML is also working on a type that is called for the Kafka. And also there are some other things like then with that cloud event type, we can define the client. So the main idea is that using that, you can define the source client and work client, the target client. And then with that client, you can send the cloud event to any brokers to not any broker, but today it is MQTT and gRPC brokers. The work agent also will be able to receive this type of cloud event and do the similar things as manifest work. So to move that, we also remove the things in the API repo. Previously, because we have cloud event things in the API repo, there's quite a lot of Go mode dependencies on like gRPC or MQTT, but currently we all remove all these different parts. So and revert that to very simple dependencies. It's only on Kube API, API machinery, etc. There's no really big dependencies on other unrelated part. So I think that's all for the current progress. Any questions, comments?
Yeah, I one of the thing that I notice is I don't import too many projects, but if I import a project with a path APIs,
Mhm.
and then I expect the API to be actually there, right? But in the SDK call Go, it seems like the APIs path only has not actually APIs, but the helpers. So
Yes,
I'm wondering maybe it might be. I don't know. I don't know. I guess I want to
we don't
see
call
what
it
others think as
APIs.
well. Yeah, if it can be renamed to APIs helper or something. But I don't import too many projects, so I don't have a good context. But usually, if it's APIs path, there's the actual APIs there. But not in this case, so it's a little bit strange.
Okay,
That's all the opinion. I mean, that's all the comments I have.
okay. I will think about that.
Anyone else? Any questions? Any comments for QJ? If not, that was really great, QJ. I really like this separation of concern. It makes importing the stuff easier.
Thank you.
And the next topic, I think you mentioned it was.
Yes, Zhujian, I'm not sure if
Yeah,
you able to
yes.
demo. Yeah, okay, thank you.
Yeah. I want to show a demo about the integration OCM with Fluid. Uh, First, let me share my screen. Uh, I can't find. Sorry, wait a minute. Can you see my screen?
Yes, we can. We can see the fluid
Okay.
page.
So, Fluid is an open source Kubernetes native distributed dataset orchestrator and accelerator for data intensive application. And so we did some work to integrate the Fluid with OCM, and we use a add-on template, and the addon template is hosted in the addon country repo of fluid addon folder. So I want to show a demo to for how to deploy the fluid as an add-on in OCM environment. So I will use a CAN cluster to apply this fluid add-on template and enable the add-on for the cluster one, and then we'll uh, 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 we'll verify the fluid add-on is functioning and using the fluid get started doc. Okay. Uh, so this is demo video. Okay. So first, I will create a CAN cluster. Yeah, and then I'll use cluster ADM to deploy OCM. Yep, now OCM is deployed. Next, we'll deploy the fluid add-on template. In the deploy add-on template folder, there are two files. One is the cluster management add-on CR, another is the fluid add-on template CR. After applying these files, we can check the add-on template is created. And next, we will enable the fluid add-on in the many cluster one, use cluster ADM CLI, and then we'll check the add-on status. So we can see the fluid components were deployed on our CAN cluster, and the add-on status is available now. And next, we will verify the fluid components I installed in the main cluster fluid system. Yeah. Then we will verify the fluid add-on is functioning using the fluid get started doc. So in this part, we will create some CRs introduced by fluid, like the data set and runtime, and we will create an application to use this data set. And yeah. So we can see this API YAML and it's using the PVC demo PVC, and this demo PVCs are uh the data site, the mounted data site. So after applying this application, first we can use some, or we can download some data in the application container. In this demo, uh, we'll copy the Spark file to div now, and this will catch this file in the data site. So we can say copy this file to div now. It used about 2 minutes the first time. Then we will destroy this application and recreate it and use the data again. Yeah, we'll recreate the application and try to access the same file. Yeah, you can see um, it takes less time than the first time. Yeah. So it only showed the simple function of the fluid. It's just a demo. There are other functionalities we can try. Yeah, I think that's all. Any comments?
Yeah, sorry, Julian, could you also talk a little bit about like is that so the I mean how difficult it is? Like is that easier to deploy the add-on or it not deploy the development with the add-on? What's
Oh, I
thing
think
that yeah.
I think it's not complicated. We can use let me we can use class ADM CLI, and there is an create option, and so we can use this tool to create the fluid and other add-ons. So for example, I will create engines add-on, uh, use the class ADM, create is this add-on name, and that chef is for what resources that we need to deploy it on the managed cluster. And we, and hub registration indicates whether the add-on agent needs to access resources on the hub cluster. Yeah, and so it's pretty simple. And this is a add-on template version. And override means if this will override the existing add-on in the cluster. So I think it's simple. Okay.
So this tool creates the YAML fest for the add-on template, right? And then it wraps the deployment inside.
Yeah. The
Oh, I see. Okay.
yeah, the chef will wrap the YAML files that we want to deploy on the many cluster add-on agents. For example, it could contain some deployments, some role bindings, or many source account. Yeah.
Thank you. That's great. Thank you. Any other questions for or comments for Juje?
I have a question. Rujen, did we have a chance to demo this to Fluid and further discuss about another solution proposal?
Not yet. We just recorded this video, and I think first we will send this video to them, and maybe later we can book a meeting and have some discussion about the Fluid community.
Great, thanks.
That's actually a great point, Yuan. Yeah, that will be great if we can have some kind of community collaboration. And then in the doc they'll reference OCM. That'll be quite cool. Just like how Argo CD with Josh contribution and then with the other contributions that we did, Argo CD docs kind of reference OCM a bit. So that'll be really good. And it seems like the Fluid project has been picking up, since the AI boom lately. So yeah, Yuan, that's a really great point. Thank you.
Yes, and currently in this demo video, we create this Fluid CRs or resources, and just on the main cluster directly. Chujian um, mentioned it's maybe it's better to create these resources on the hub cluster by our manifest works. And yeah, I think that's a good idea.
Yeah, I
Thanks.
think for by policy, I think that's because Fluid is more like a way that you can accelerate the data access during no matter whether it's AI or uh big data runtime. So it might be quite interesting if there's a way that because we are multi-cluster, so there is possible that the data is in one cluster and their runtime is in a different cluster. So there could be some kind of orchestration we can do to help them to like easily achieve their features with data and for example the data locality and the runtime, or if any other thing they could do to accelerate the AI across the cluster.
Yeah. I think based on our discussion last time with Floyd community, I think they truly have these requirements. Yeah.
Thank you, Kuchen. Yuan, were you gonna say something? Sorry.
No further questions. Thanks.
Okay. Any other last comment question for Kuchen? If not, I think that's all the topics that we have today. Thank you everyone again for joining. Have a nice day and have a nice night. Take care, everyone. Bye.
You.